Okay, so we are now going to the second part, which is the one that was atrociously done. Okay, somehow when it comes to your graph, you go downhill very, very fast. I do not know what happened. Okay, number one, the question asks you to plot what against what? The question asks you to plot C against square root of D. Now, so far so good. None of you have mixed up the two, alright? So, you have given me the C on top and the square root of D below, but there is a catch. Number one, you must remember that for this axis, number one, the marking criteria is it must be the correct axis. That means C is on the y-axis and square root of D is the x-axis. And then it must be labeled with units. So guys, when you look at Kian Leong's answer, he has a C and also have the units, which is a correct representation here. Alright, you might want to write this down first, the marking scheme for this one. But when you look at his x-axis, there is a small mistake, but the mistake is forgivable. Why is it so? Okay, you write this down, I'll explain to you the x-axis case. Done it? Okay, I'm going to show you the x-axis now. So when you look at the x-axis, actually Kian Leong has also labeled root D, but the only problem is that he doesn't have the units. But it is forgivable because he has already forgot the unit in the table. So if I penalize him again, it will be a double penalty. So usually in O-level practical, they do not double penalize, so this is a forgivable mistake, right? So don't worry. But remember, this must also have a unit. So that's for the first mark. What's the second mark? Okay, the second mark is for your size of your graph and the size of your graph. Yes, the size of your graph. Okay, the size of the graph from the first plot point, which is this guy here, to the last plot point, which is this guy here, must be how many by how many squares? Can someone tell me how many squares? How many squares horizontally? 1, 2, 3, 4. Pass or fail? Fail. You must be 1, 2, 3, 4, 5. At least 5. That's why this is labeled fail. And then the other one is vertical axis. How many? 6. 1, 2, 3, 4 only. My goodness. Kian Leong, where do you grow up from? Who is your physics teacher? Oh yeah, it's me. Okay. So what happened is that this must be greater or equal to 5 big squares. This must be greater or equal to 6 big squares. Alright. So guys, this is the most common error in this question. Many of you gave me a very, very small square. Alright. Very, very terrible. Very, very saddened by this. Now guys, how do you make sure that you have a big square? I'm going to tell you now, but please do your correction first. Okay, are you ready? Now, the reason why you have a small square is because students has a tendency to want to start from 0, 0, right? Because you are taught in math, start from 0, 0 so you can find the y-intercept, right? I am absolutely supporting what your math teacher says, but the thing is, if you start from 0, 0, you are being restricted by the size of the graph. You understand or not? Okay? Because if you start from 0, no matter how, if your last data is 600, you can only plot until here, you cannot plot anymore. If you extend it, it may not be large enough. Understand? So guys, can I just check, anybody has one where the size is correct one? Size is wrong. Samantha, yours also wrong? Okay, Ahmad again, alright. Clever boy. Okay, Ahmad's one is so nice. Okay, so Ahmad's one is a good example of what you should do. Okay guys, you don't have to start from 0, 0. When you don't start from 0, 0, you can have the advantage of making your graph as big as possible on the y and x axis. Alright? So the only argument against it is this. If you don't start from 0, 0, there will be a tendency for what? Yeah. They might ask you to find y-intercept, right? Then you cannot find how? Use the formula. If you cannot find y-intercept, they want you to find y-intercept, and then you never start from 0, 0. Use the formula, alright? Y equal mx plus c. Anybody has a 30 cm ruler? Okay, 30 cm will do. Okay, Kian Leong. My goodness, your one is like toss. I don't want this one. Don't use this one. Use another one. Hey, this is not Avenger. You're trying to show off your toss hammer or don't know what. Okay, you don't need this one. Just get the standard one here, like that. Alright. Okay, now guys, look at this graph. The next mark is best fit. Auntie and uncle, can you tell me whether this is best fit or not? What is wrong with Ken Leong's graph? Super not best fit. Can you tell me how to best fit? Anybody want to challenge and come out here and do a best fit? Ahmad? Huh? Don't want lazy okay, never mind. Jacob, come. Show me your best fit. The guy with the pink bag. Come on, give me a round of applause, Jacob. When you walk past, I just give your best. You're terrible. Okay, show me your best fit.
Yeah, need to see.
Clever, you do a vertical first. You see, he's so clever. Your hand must move a bit higher a bit.
I cannot see.
You cannot see, can you got two eyes, but you cannot see.
So around here.
Okay guys, do you realize that there is a much better fit? So this is the problem. You still have problem with best fit. Now, if you have problem with best fit, don't worry. I will give you a practice paper to do. Must remind me, latest by next week, I'll give you a practice paper to do. Okay, the practice paper with the model answer. Can? Alright, Wow, you also draw. I like you. Alright, this is best. Okay. Now, is it correct? One down, one up, one up, one down. Fantastic. It's so perfect. Okay, can you understand? So this is the best fit that I want to see. Alright. So this is number 3, the third mark. And number 4, what's the fourth mark? Joseph, good morning. What's the fourth mark, Joseph? You are Joseph, your name is Joseph. Joseph, you repeat what Jacob said. Plot points, alright. The plot points must be correct, okay? But it's amazing that you will have 5 data to plot. I have 40 times 5 data to read. You can still make a mistake. You have only one job, I know. Okay, so the fourth one is plot points. I'm not going to write down here, you should know. Okay, now we come back to this. But before we come back to this to find the gradient, what must you show on the graph? You must show your gradient triangle and your gradient coordinates. Now, I am very impressed by the class. You have been well guided by your physics teacher, or it's me, okay. To have these coordinates written down, fantastic, alright. Please do that, okay. Don't let me remind you, some of you draw the triangle and then just leave it there without the coordinates. Don't do that, You do that, I also minus mark. You must have the triangle and the coordinates. You must give me nice one. And then you know what? You are amazing. You have the coordinates, still can read wrongly one. You only have 2 coordinates. I have 2 times 40 students to mark. My goodness, amazing. So what happens is that after you read the coordinates, you draw it here. You solve for it. By right, you're supposed to get 3 marks. Alright. The reason why this guy did not get 3 marks is because it must be. The criteria is must have gradient, triangle plus coordinates. This is the first mark. If you don't have this on your graph, no marks for this part. Number 2 is correct calculation. This is the second mark. Number 3 is 3SF. Now, is there any units? Are there any units? Do you have to include the units? Yes or no?
No.
Remember, gradient has no units. And I'm very impressed. Many of you were able to show me gradient has no units. Very good. Okay? Let's carry on. Now, the next question, which I think your answer even better than my last year Set 4. The last year Set 4 sit for this for their prelim. I think you all did better than them. So what happened is this, you are supposed to find the location of the C when D is 35 mm, right? So you cannot directly use 35, you must use square root of 35, which is 5.92. Very impressive. Most of you did this. I think none of you did the opposite. Joseph, are you okay, Joseph? You are worried for someone, is it? Okay, never mind. I'm not going to ask. Okay, so what you do is, you go to here, and then you find the 5.92, and then you produce up, and you produce to here, and you read from the graph. Now, I don't think I penalize you for accuracy. I think I allow you for method mark, which is very impressive. Most of you got this. Well done. Okay, and then you also included the units. Very, very good. Okay, so far, most of the skills are there, except the graph is terrible. All right, the graph is the most terrible part of the whole thing. And the next thing that is the most terrible is at the end of every question, they will ask you some dumb questions, and you cannot answer them. So you are okay. Never mind. It's too dumb for you, all right? Okay, I understand. Okay, so no matter how precisely you measure L, okay, it is unlikely, it's likely to cause the values obtained of C to be inaccurate. Okay, suggest one reason why the use of the length L may lead to errors in C. Now, class, why is the L error? So what you should do is follow the instruction. What does figure 1.1 tells you? Go to figure 1.1. Don't get here. I'm going to answer yourself. Now, class, look at figure 1.1. What does it tell you about L? Now, when you look at this L, the L is measured at the bottom right. Now, what happens if you measure at the top? It's longer, right? So what can you say about L? Is L consistent? No, L is not consistent. Alright, so how do you explain in words? It's only 1 mark. It's only 1 mark. So what can you write? The figure shows that L increases as the water level rises, right? Okay, I think we can leave it at this, even though it's a bit big, but I think this will do. Alright, it shows that L increases as water level rises, so L is not a constant value. Okay, can I move on to the next stage? Now, will this error cause the values of C to be higher or too low? Explain your answer. Now, this answer was very badly done. Now, let's write down the formula again. The formula is C equal to 6L over TA, right? Now, let's write this down and examine this question as a whole, all right? Now, as the depth increases, what will happen to L? Will L be actually higher or lower? The actual L will be Will be higher or lower? Higher. Huh? But this L is lower than its actual L. So this L is lower than its actual L. So do you think that this value calculator will be lower or higher than its actual speed? Lower? Because the L that you use is the original L, which is the smallest. Right? The lowest point is the smallest, right? So because the L is the lowest, is the smallest value, right? So the calculation of CR will be an underestimate. Understand? So that's how you interpret, alright? Many of you could not do it. Now remember, these three questions are very well written. O-level pure physics, right? Questions are similar to this, which is very interesting. Interesting and doable. But you must not be rigid in your answer. Okay, so how do you explain? So you can say using the formula C equal to 6L over TA. So using the formula C equals 6L over 2A TA, alright, the value of L used will be lower than the actual length as that increase. So C is calculated too low. Okay, so that's the answer. How many of you got the answer correct? I think only 2 or 3 of you got it correct. So it's about the math, the concept behind it. Okay, don't worry. Don't panic if you get it wrong. Just remember, always earn the lower hanging fruit marks first. What are the lower hanging fruit? Table must be full marks. Graph must be full marks. Gradient calculation must be full marks. Accuracy is a give and take. But table, graph and gradient calculation, all these add up about 75% of marks. So if you have already scored 75% of marks, the rest is just bonus. Okay? Let's go to the last question now. So the last question is, suggest and explain one other source of error which is likely to affect the accuracy of C, human reaction error. Now class, I need to tell you the truth. The truth is, I will not accept human reaction error. Why? Why do you think we should not accept human reaction error? Yes, you already measure the time 3 times. Okay? So this is not a very nice thing to write down as a human reaction error. Okay? But if there is no human reaction error, is there any other ways you can write? So what you need to do is to think about the experiment. In which part of the experiment do you think is very hard and very troublesome? When the thing drop. Okay, then after that what happens? Is there something about the whole measurement that is troublesome? Now, can you exactly tell me where is the crest of the wave? So are you very sure that the crest of the wave just hit the side, then you stop the stopwatch? So isn't that an error by itself? Although it's similar to human reaction error, but it's not. It's a human judgment error. So what do you call that? How do you call that? It is difficult to what? It's difficult to judge the exact points when the crest So it's difficult to judge the exact point when the crest hits the wave, which is the side, sorry, affecting the timing of T1, T2, and T3. Now, is there another possible error? The other possible error is pretty mind-blowing. If you hear what I want to say, right, you will say, yeah, how come I never think of that? How come I never think of that? You think of it, I want you to think first. I'll see whether anybody can think of this error. The distance, yeah, what about the distance? To give you a hint, the wave, you assume that the wave travel in what direction? Are you making an assumption about the motion of the wave? You understand what I just said? What if you drop the thing, but that thing drop, it did not drop perfectly, and then the wave travel like that? You understand or not? Because we are assuming that the wave travel like that. Right? Sometimes the wave may not travel parallel to the surface, right? Why would this happen? This will happen when you did not drop it uniformly, right? When you did not drop it uniformly, what happened is that the crest might not move like that. It might move like that. But that slight change of movement, right, you could not judge. You just assume that it's alright. So how do you put in words? The mode of dropping. Or you don't have to say about the mode of dropping, you can just say what? The wavefront is what? The wavefront is what? The wavefront might what? Might not. Shortcut, short form, you know what is this, right? Parallel. Okay, I don't want to use the word parallel. Perpendicular to the sides. Of course, there is a third error. What do you think is the third error? The third error is quite simple one. Anyone can tell me what's the third error? You look at the plastic container you're given, right? Is it like uniform at the bottom? The bottom is not uniform, the sides are deeper, right? The center is shallower, right? So you can say that the bottom is not perfectly uniform. Some parts are deeper, affecting the depth. So that one is the easiest one. Alright, but this is up to you. Okay guys, we come to the end of this part.